All right, welcome. Think of this as your first day on the team, and your mission right from the get-go is to really master how we build AI agents that are powerful and, most importantly, that actually work. So let's get right to it.
Okay, let's dive right in. We're moving way past the simple chatbots you might be used to playing with. Your job here is to build robust, intelligent systems, agents that can take action on their own and get real things done in the world.
So first things first, let's get the fundamentals down. We need to be absolutely crystal clear on what makes an AI agent an agent in the first place. This distinction, well, it's the foundation for everything else we're going to build.
Just look at the difference here. On the left, you've got your standard chatbot. It's basically just a large language model. It's passive, It just sits there and waits for you to say something. But on the right, that's an agent. It takes that same LLM, but bolts on a toolkit, a memory, and a reasoning loop. And that's what makes it autonomous. It doesn't wait. It actively goes after a goal.
So what makes these agents tick? Well, at the heart of every single one of them is this simple but incredibly powerful three-step cycle. You can think of it as their engine. Let's break down exactly how it works.
It all kicks off with observe, where the agent just sucks in all the context it can get. Then it moves into the think phase. This is where it looks at its goal, looks at the context, and comes up with a plan. And finally, it acts. It actually executes that plan. And the key is it just keeps doing this over and over, getting a little bit smarter with each cycle until the job is finally done.
And here's where it gets really interesting. Each one of these steps, observe, think, and act, isn't set in stone. It's a lever you can pull. You can optimize each phase of this loop to make your agent faster, more accurate, and just flat out better at its job.
So let's make this real. Imagine a simple research task. Find 10 good sources on a topic. First, the agent observes the goal. Then it thinks, right? It goes, okay, scientific papers. My web search tool is the right move here. It then acts. It runs the search. On the next loop, it observes the results and sees, let's say, only 5 sources. So it thinks, nope, not done yet. I need 5 more. And it acts again. Maybe it refines the search terms. And it'll just keep doing that until it hits that goal of 10 plus sources.
So an agent running that basic loop, that's a great starting point. But to really level it up, to make it truly efficient, we need to give it 2 things: a persistent memory and a set of repeatable skills. And we do that with what we call system files. Just think of a file like this Gemini.md as the agent's long-term memory. Any rules or preferences you stick in here, like, say, always use light mode, get loaded automatically at the start of every single conversation, so you never have to repeat yourself. And next up, we've got skills files. Now, these are a total game changer. They're like prepackaged instruction manuals for your most common workflows. If you have a complex job you do all the time, you just save the instructions as a skill. This turns your flexible do-anything agent into a specialized tool that does that one job perfectly, the same way every single time. All right, now for what I think is one of the most powerful ideas here: building agents that don't just follow a set of rules, but that actively learn from your feedback and get better over time. So imagine an agent just built a website for you, but it used dark mode, and you wanted light mode. You give it that one simple piece of feedback. Now here's the magic. Instead of just fixing it for this one instance, a smart agent is programmed to take your feedback and write it as a new permanent rule right into its system file, right into its long-term memory. This whole process has a name. It's called a self-modifying prompt. The agent is literally rewriting its own instructions based on what you told it. It's never going to make that dark mode mistake again because its core programming has actually improved. It just gets smarter with every project you do. Okay, so everything we've talked about so far, that's all for a single agent. But the real force multiplier, where you see these massive leaps in quality and speed, is when you get multiple agents working together as a specialized team. To build any great team, you need specialists, right? You wouldn't ask your star designer to write back-end code. It's the same thing here. As you can see, a model like Claude is fantastic at project management, what we call orchestration. Gemini is a whiz at front-end design, and something like Codeex is an absolute beast for back-end programming. We lean into these specializations.
So, for a big job like building a web app, we'll assign an orchestrator, usually Claude, to be the project manager. It'll break down the goal, hand off the back-end work to our specialist Codeex, send the front-end stuff over to Gemini, and then its final job is to pull it all together and make sure it works.
We also build in quality control using these verification loops. So an implementer agent will do the first pass, then a totally separate reviewer agent with fresh eyes comes in and checks the work for mistakes. And if it finds any, a third resolver agent is brought in to make the fix. It's basically an automated AI peer review, and it's incredibly effective. And for the really tricky, complex problems, we can even spin up these agent chat rooms. Imagine this. We create a whole team of agents with different personalities. One's a pragmatist, one's a contrarian, one's a user advocate. And we just let them debate the best way forward. That creative friction they generate, it helps us find hidden problems and really pushes the final solution to a much, much higher quality. Okay, to wrap up your first gay crash course, I want to give you the single most important tool in your toolkit. This is the checklist I want you to use before you kick off any complex agent task. We call it the prompt contract. Before you start, you have to explicitly define the goal. Then you set your constraints. After that, specify the format. And here's the absolute kicker, the most important one: list the failure conditions. Forcing yourself to think about what failure looks like right at the start is maybe the most powerful way to guarantee you get the result you actually want. Look, it all boils down to this, and it's so important. The quality of your output is a direct reflection of the quality of your input. It's that simple. As you can see here, if you give a vague task, you're going to get a vague result. But if you create a precise contract, you will get a precise outcome every single time. And that's it. You've got the fundamental loop, you've got the tools for giving agents memory and skills, and you've got the strategies for making them work as a team. You have all the building blocks you need to create agents that actually get the job done. So, welcome to the team. Now, what are you going to build first?